Hi, everyone. My name is David, and I'm here to talk about how do we navigate the challenges of generative AI from an insider risk perspective. So first, we're going to talk about what is generative AI. And secondly, we'll talk a bit about how does it work. And that'll give us more intuition and background into how we guard against some of the risks and solutions. But first, who am I? My name is David. I'm the head of platform for EchoMark. Prior to this, I was the AI platform lead at DocuSign. So this was building the research and inference systems. So the systems that did the machine learning training as well as serving the machine learning models. Prior to that, I was a co-founder at two different startups, which were both acquired. And so I've been around in the startup world as well as the larger companies as well. My background is in machine learning as well as computer science and business from UC Berkeley. All right, so what is generative AI? All right, generative AI refers to a class of artificial intelligence models that can create new content, such as text, images, music, and more, based on the data that they've been trained on. And so the key difference here from traditional ML is that traditional ML has narrow outcomes. So something like spam classification, you give it an input and it gives you a narrow set of outcomes. Is it spam or is it not? When it comes to insider risk, what's important to focus on here is that generative AI has open-ended outputs. And so when it comes to traditional ML, you had control over what the model outputted. So you had a lot less in terms of threat vector for data leakage. It's either spam or not. When it comes to the open-endedness of generative AI, it makes putting guardrails into the system that much harder. However, it is indeed this open-endedness and the quality of the generated output that makes Gen AI so transformative. So just to touch on a few examples, in the front office part of the graph here, for example, you can use the history of your customer service interactions and ratings to train an empathetic chatbot that is always available and can get you the answer you need very quickly. When it comes to product development, now code generation is incredibly accurate and can make both an individual developer 5 times faster, but it could potentially obviate the need for other types of development altogether. The quality of these generative AI models is just that good. So, how does it work? Let's take a look. And with this look of under how these models work under the hood, it'll give us a more nuanced understanding of what the risk factors and threat vectors are. So let's focus on one type of generative AI, text generation. So one of these models is something you're probably already familiar with, something called GPT, which stands for Generative Pre-trained Transformer. All GPT models are something that we call a language model. So what is a language model? At its core, when you give a language model an input sequence, it gives you a probability distribution of the next word. So if we look at the example here, the students open there and it'll give you a probability distribution of what that next word might be based off the prior inputs. It's worth pausing here to emphasize that generative systems are just this. They take an input and predict a likely output sequence. They are probabilistic and trained off of the correlations and patterns found in the data. So how does one build a language model? Well, first, you need a very large corpus of text, and the obvious source here is the internet. Going back to traditional ML, in the past, you had to have labeled data to train an ML model. So when it comes to something like spam classification, you needed a bunch of emails and you needed to label them whether or not they were spam. For language models, researchers found out that you could do something called self-supervised learning, which actually doesn't require labeling. The idea is that you can generate input-output pairs from the sentences themselves, in effect, automatically creating the labels. So, for example, you can take a sentence of text and break it up in the middle and predict the right side using the left side as input. So this is also known as predicting the future from the recent past. And so you can imagine for a particular document with multiple paragraphs, you perform this technique across all the sentences and you multiply this across all the data that you have on the internet, you suddenly have a lot of data to train on. And after training this on a massive scale, you actually get a system, a language model that is able to model human language and do exactly what we saw on the previous slide. So the key takeaway here is that during pre-training, you use massive amount of internet scale data to learn the model of language. So what's next? Well, one thing about LLMs and LLM, the L part here is just large in terms of the number of parameters for a language model. The one thing about LLMs is that they generalize incredibly well to what we call downstream tasks. So back when it comes to traditional ML, when you had multiple tasks, you needed specific training sets for each of those tasks. So AI 1 through 6 here needed specific training data for those particular tasks, and those would be labeled data. LLMs and what others call foundation models can be fine-tuned to a different objective. And fine-tuning in this case means using a data set and fine-tuning, further training that foundational model to that particular task. So for example, you can use a customer service question and answer database to adapt your LLM to answering customer service questions. And so what is so revolutionary here is that you don't need that much data to do so. You can get really, really good performance on much smaller data sets, so something on the order of hundreds, even thousands of examples. So, and in the past, for traditional ML, for each of those training data sets, you would need a lot of data, a lot more than hundreds of thousands to get good performance. So the key takeaway here is you usually fine-tune an LLM to your needs with your own data set, proprietary or not. Most folks are not in the business of pre-training an LLM from scratch, the thing that we saw in the prior slide. Most folks are taking a foundation model and adapting it to their particular need. Okay, so that's enough with the mechanics. What could possibly go wrong? Well, first off, since it is a probabilistic process based off the training data, it'll do its best to give you an answer. And so this can lead to an effect called hallucination. And now that you have a better sense for what the training process is and how it's all based off the data it's fed, you can have a better intuition into how hallucination can actually occur. Given this input sequence, it'll do its best to give you an output sequence. Okay, so what are the other risks here? We already touched upon hallucination and the creation of misinformation, but there's also bias and fairness. Models can amplify any of the biases present in their data. There are privacy concerns, so a model can potentially disclose or leak confidential information from its training data set. And this is because the output is open-ended. There's the threat of deepfakes and security using deepfakes. So sophisticated spear phishing attacks now have full natural language capabilities at their disposal. There's also copyright and plagiarism, as well as job displacement concerns. We're going to focus here in terms for insider risk on data privacy and potential leakage, as well as content authenticity. And this latter one is much harder. How can you actually discern AI-generated content from human-generated content? All right, so what are some of the solutions to these problems? Let's start with data privacy and leakage. This is the most pertinent when you actually want to use an LLM in your organization's workflows. And so a lot of the advice here comes from if you wanted to take an LLM and train it on your data set, most likely in the fine-tuning stage. The high-level takeaway here is it's not rocket science. It's establishing a strong data governance and compliance program, as well as robust procedures for model QA. So more specifically, all data in the organization should be classified for its level of sensitivity, and only the data that is deemed appropriate can be used to train the model. But you also have to bake into your procedures data audits, data sensitivity training, as well as having processes in place to spot potential data leakage, also known as adversarial training. The magic of Gen AI is in its data, so you have to run a tight ship when it comes to what is fed into these models. It's also worth mentioning there are risks around using third-party APIs. You are transmitting potentially sensitive data over the wire, and you have to be careful about what the terms are of that API, and whether or not they can use that data for training, for future training. And so in some cases, it's not immediately obvious that you're even using a third-party API. So for example, an auto-completion system, which you use to see in document processors, as well as email systems that give you that suggestion of what comes next. They're using the actual context of the entire email to make that prediction. And so you just have to be careful of what the terms are there, especially if you're dealing with sensitive information. The next risk area is content authenticity, and this is a much harder problem. It's actively evolving, and because the technology has gotten so good, it has become an arms race with detection tools. So the first solution is the obvious one, qualitative analysis. And so for things like generated text, you can look for the consistency and pattern, the tone, the writing style. For images, you could look for visual artifacts, facial features, background anomalies, unnatural skin tones. The key thing here is that employees should be trained to use qualitative analysis to spot deep fakes. This is very similar to how, with heightened awareness, comes heightened vigilance in the spearphishing world. Next comes automated detection tools. These are hit or miss. They're not a silver bullet. So if you have a particular threat vector in mind, it can be helpful to look for a tool that helps for that particular risk. There are some tools like GPT-0, OpenAI's own text classifier. Turnitin.com has something for plagiarism. Again, these things are hit or miss, and they're kind of dependent on what the threat vector is. It's worth touching upon AI watermarks in generated content. These are self-imposed by the model builders themselves. And so for text generation, in that language model example you saw, when sampling for the next possible word, they will pull from a set of words, predetermined set of words, that make it more likely that the text was generated by that model. And so this has actually been shown to be easy to reverse engineer. So that means someone can both strip the watermarks and they can even impersonate the model. So not a foolproof technique by far. And finally, we're seeing the emergence of open standards for content authenticity, such as C2PA, which is a shortened term for Coalition for Content Provenance and Authenticity. They recommend a multifaceted approach of having a cryptographically signed chain of custody on the data, so that's the secure metadata, along with invisible watermarking and fingerprinting of that data. This standard is growing in popularity. There are some large industry folks who are also backing it. But the challenge here with any open standard is that it has to be used by everyone and widely adopted for it to be effective. So none of the above here is foolproof, and it's really an active area to keep an eye on, as content authenticity, I think, will become a growing area of concern and something that we all have to be wary of as generative AI technology gets better and better. All right, so what does this mean for insider risk? Essentially, we have a new frontier. There are new data flows that could subtly exfiltrate sensitive data, and so that's the data privacy and leakage that we talked about before. There's new way to launder watermark data using generative AI models to evade detection. So you could use generative AI to paraphrase existing documents, recolor images, and strip watermarks. This is a way to actually clean your data if you wanted to get a version of it and have it be untraced. And finally, there's unprecedented realism in security attacks. And so this is for social engineering and spear phishing. Right now, generative AI, from an image perspective as well as text generation perspective, is getting so good that it has become a real concern on the sort of security attacks and the sophistication of those security attacks. All right, thank you very much for listening to the talk, and hopefully you learned something about generative AI and how it pertains to insider risk.
EchoMark's revolutionary technology protects your files and messages by individualizing them for each recipient. When everyone's file is automatically marked with identifying information, leaks can be traced to their source. For added protection against leaks of your sensitive communications, you can also create uniquely phrased messages for each recipient. EchoMark gives you complete control to ensure that your original tone is maintained. If your content leaks in full or even via mobile photo, you can use EchoMark's investigation tools to identify the leaker quickly and easily. Try it yourself for free or book a demo with us at EchoMark.com.